So in our previous class, we managed to prove some of the identities, all right? So we are going to have a continuation from what we had working with our identities, proving of identities. As I said, it is always important that you work with the most complicated side of the given part that you are going to prove. On question number 6, we are given an identity that we are supposed to prove in this case. That is left-hand side equal to tan squared of x. So guys, we have got much complicated side here. We've got much complicated on the left-hand side. So we're going to pick or to choose the left-hand side and see what we are going to have at the end. So on our left-hand side, we are given the cos of x minus cos cubed x, everything over the cos of x minus the cos of x times sine squared. So this is sine squared of x. So they are saying we are supposed to obtain a tan squared of x from here. How is that possible? All right, let's figure out from the numerator. The cos of x, we also have cos of x. It is common, so you can factor that one out, factorization from our algebra. So you can factor out the cos of x, the one with the smallest exponent, which is this one. If we factor it out, it's cos x divided by cos x, which is 1 minus cos cubed of x divided to cos of x. So it will be cos squared of x. We'll remain with the 2 of them. Remember, there were 3. So if we divide, we're going to remain with 2. Everything over what? In the denominator, we can see again the cos of x is common between these two terms. So we're going to factor it out just like the previous case. So let's factor out the cos of x. What are we going to have? Cos of x divided to cos of x. That is 1 minus this cos of x, and this one was going to cancel. So this one was going to cancel, guys. You remain with what? Sine squared of x. So it was going to give us sine squared of x. So this is it. As we have the numerator and the denominator, this is a product. So you can even cancel this, cos of x and cos of x. But these two cannot cancel. Cannot cancel. So we are having 1 minus cos squared of x over what? 1 minus the sine squared of x. This is where we are. Remember our previous case that we had. From the cos squared of x plus the sine squared of x is equal to 1. We managed to make cos the subject, and we said cos squared of x is equal to 1 minus the sine squared of x. Or we can make the sine squared the subject, meaning to say it's going to be the cos to the other side. It will be 1 minus cos squared of x. Remember, these are extensions from this identity. And this is exactly what we are having here. 1 minus cos squared. Where do we have 1 minus cos squared? Here. What is its equivalent? That is what? Sine squared. 1 minus cos squared is what? Sine squared. So in place of this 1 minus cos squared, we are going to have sine squared. So this is sine squared of x over what? 1 minus sine squared. In place of this, we are going to have cos squared. We are substituting, at least we have a single term. Sine squared over cos squared. This is what we have. Guys, knowing that a sine of x over a cos of x is equivalent to tan x. So it means if this is squared and also this is squared, this will be tan squared. So this is exactly what we have here. Sine squared over cos squared. So that is going to give us what? Tan squared of x. Just like that. Exactly what we are having on our right-hand side. This is what we're given. The tan squared of what? The tan squared of x. So this is it, guys. Factorization where it is possible. Apply that factorization. Cancel the numerator to the denominator concept. Then apply your identities, guys, further where it is applicable. So you have to work out typical questions like these to figure out, guys, to figure out. Let's see on number 7, the whole part on the left-hand side is supposed to be equal to 0. All right, let's see. It's an interesting question indeed. That is the sine of theta over what? The tan of theta. All right, sorry, let us just take it. Let us just start to solve, guys. Left-hand side is equal to, take our left-hand side, sine of theta over what? The tan of theta minus the square root of 1 minus sine squared theta. Square root of what? 1 minus sine squared of theta. Everything is supposed to give us a 0. All right, let's check. Remember here, we just talked about the 1 minus sine squared. 1 minus sine squared. It's what? A cos. So this is cos squared. So we are going to have the sine of theta over the tan of theta minus the square root of what? 1 minus sine squared is what? Cos. So this is going to be cos squared of theta. So we are going to have the sine of theta over the tan of theta minus the square root of cos squared is just like you are given the square root of x squared. It is what? X. The square root and the square neutralizes. You remain with what? X. So the square root, where you've got a squared, just going to remain with what? Cos. So that's cos of theta. But we can see that is where we are, because we could have simplified the tan here. But because of, guys, we just need to see. Answer is 0. So can we subtract here? It is impossible. Like, okay, no problem. Let's take out the tan as we had it before so that we can try to simplify here, because you can see we have to subtract. But how is that possible? Let's figure out about this. There's something here hidden here. The tan, remember, it is what? Sine over cos. So there's something that we can bring out here. So it will be like this. It will be the sine of theta divided to, what are we dividing? To the tan, where the tan is what? Sine over cos. So it will be divided to sine theta over cos theta. This is what it means here. Sine divided to tan. So it's sine divided to tan minus the cos of theta. So this will be equal to, remember, we are having a division. This is like over 1. Division. We are supposed to introduce the multiplication where the division is. Introduce the multiplication sign. So it will be like this, sine of theta over 1. The moment you introduce the multiplication sign, what are you going to do? You invert the second fraction, interchange that one. The denominator to the numerator. So it will be cos theta over what? Over sine theta. This is what we have. Minus this one, the cos of theta. So this is where we are. What can we do? Product. We can cancel the numerator to the denominator. So this is 1. So you're going to multiply 1 times cos of theta. That is cos of theta over 1. Guys, cos of theta over 1 is just cos of theta. Minus this one. Remember, we still have this. So you're going to subtract the cos of theta there. It's just like 1 minus 1, which is what? Which is 0. 0 cos theta. It's what? It's a 0, guys. That's a 0. So this is exactly what we have on the right-hand side. Our answer is supposed to be what? A 0. Just like that. So this is it. Just do as many questions, all right, to cater up your revisions. You have to figure out the question, the answer that you're given. It's just a matter of playing around, guys. Like I said, prove you're already given the answer, all right? You're already having the answer. Let us consider question number 8. So on question number 8, we can also choose to work with the left-hand side again. It is complicated a little bit. So let us consider the left-hand side. The tan squared of theta plus 1 is supposed to give us 1 over cos squared of theta. So choosing the left-hand side, we have got tan squared of theta plus what? Plus 1. Okay, what can we do? Tan, remember here, tan squared, tan sine over cos. So if it is a squared, it means what? Sine squared theta over what? Cos squared theta. Even though you know that 1 is sine squared plus cos squared, just leave it for now, guys. Just leave it as it is. So you're supposed to add 1 like this. So it's an addition, this one. We are talking about fractions. So 1, we know that 1 is same as 1 over 1. We know that. But let's go back also to our algebra, guys. Let's go back to the understanding of our algebra. If we are given x like this plus, let's say it's x over y like this plus 1. 1 can be written as a denominator of y like this, where we can have it as x over y like this plus, instead of us writing 1, we can write it as y over y like this. As long we are writing it as the denominator, as everything that you see in the denominator. So it's the denominator over the denominator, which is what? Which is 1. As long you write it that way, it does not affect, because you know that you simply add what? The numerators together, x plus y over what? Over y. If you understand this from your algebra, guys, it means we can also do the same thing. Instead of us writing this one, we can write it as a denominator, this one. What is our denominator? What is in the denominator? What is in the denominator is what? Cos squared of theta. So you're going to have cos squared theta over what? Cos squared theta. As long it is what is in the denominator, as it is. Meaning to say, if it is an expression, you must take it as an expression. If it is a single term, you must take it as a single term, but divide that term. It gives you the same one. The only part of doing this, guys, the advantage of doing this is that we want this concept here where the denominators are the same. Mathematically, if your denominators are the same, you just combine the numerators under that denominator. You just combine these numerators together. So it will be what? Sine squared of theta plus cos squared of theta. This is what you're going to have. Guys, we know sine squared, cos squared is what? Is 1. So this is 1 over what? Cos squared of theta. Exactly what we have on our right-hand side. Just like that, we are done. We cannot simplify further because we can see this or answer. If it was extending, we have to extend according to what the answer is. But according to our answer, we are done. So this is how you work out these questions, guys. Just like that. 1 can be changed to any denominator, And you can simplify further, combine fractions, addition and subtraction of what? Fractions is important. Algebra is playing a major role again in our simplification. Algebra plays a major role. Number 9, we are given, that is the sine of x plus cos of x over 1 plus this. All right, let's see. Let us just take the left-hand side, much complicated. So the left-hand side is equal to what? This is, all right, the sine of x plus the cos of x over what? 1 plus the tan of x. All right. And the answer is just cos. All right, no problem. Answer is just a cos. No problem. Let's see. If we are to consider here, we can see that the numerator, there is nothing that we can do. Sine and cos. They are not squared, remember. It is not raised to the exponent of 2. There's nothing that we can do, but there's a tan there in the denominator. There's a tan. Remember, we have to get rid of this tan or this one. These are the only two that we're thinking of. If you do not see this, then think of what? A tan. Guys, this is your grade 11, just like that. Grade 12, that when you'll be talking of a lot of things there. But for now, this is it. All right? So let us see. Tan is same as sine over cos. So it's going to be interesting. Let me just separate this way, guys. Sine of x plus cos of x. This one, it's a single, like it was an expression, but we're going to take it as a term. The moment we open the brackets like this, we are taking it like it is a single term, which is being divided to 1 plus the tan of x. Let's figure it this way. All right? Even though we cannot simplify here, let's leave it like that. The sine of x plus the cosine of x. Leave it like this. Divided to 1 plus, we are now back here, tan, sine over cos. So it is going to give us the sine of x over the cos of x. Just like the previous case, guys, we saw that if we have got a condition where we are adding, like here, all right, sorry for that, like here, this part, where we are adding, we can easily combine. So you're going to have the sine of x plus the cos of x like this, divided to 1 in the denominator concept, or as the denominator of cos of x is the same as what? Cos of x over what? Cos of x as the denominator, plus the sine of x over what? Cos of x, which allows us to simply combine this. So actually, guys, I was just, okay, no problem. Just forgive me. I was just supposed to add this at once, but no problem. There we are. Let us combine because we have got the same denominator, which is cos of x. So we can simply add the numerators together. Cos of x plus what? Plus the sine of x, like this. This is where we are. It is a division. And we have this one as a fraction, and this one also can be written as a fraction because it's just like over 1. So where the division is, you see a fraction and another fraction, you can now introduce the multiplication sign. But the moment we introduce multiplication sign, remember here, the moment you introduce multiplication, the division, where the division was, we're now having a multiplication. We interchange the second fraction. So what does it mean? It means we are going to have the cos of x in the numerator now, over what? This one in the denominator, which is the cos of x plus the sine of x. This is what we have now. Multiplication, as long you see something similar, exactly the same, numerator, denominator, cancel that. This is what we see. The numerator, all right, guys, sine x plus cos x. Cos x plus sine x is the same. It's just like what I was explaining, guys. A plus B, B plus A. It is the same. So these two, they can cancel. Meaning, say I've got 1 and this was 1. So you're going to multiply 1 times cos of x. That is the cos of x over what? 1 times 1, which is 1. So this is equal to the cos of x. Is it what we have before we simplify? And can we simplify that, guys? We are stuck. Let's check. This is exactly what we have, which is equivalent to the cos of x. Exactly what we had on our right-hand side. This is exactly what we had. So we have managed to prove this. So please, guys, as you are working these questions, understand it is just simplification as you had it before. Only that you are given an answer to say your answer is, you're supposed to work out until you write your answer in that way you are given. That is the only part that has changed. So if you do understand your simplification, then you are good to go. All right, let us consider question number 10, which is the last part that we're going to have in this activity. We are given to prove again. So working, in this case, I'm going to also work with the left-hand side. That is, from the left-hand side, it is equal to what? The tan of theta plus 1 over the tan of theta. All right, the tan of theta. Remember, guys, that tan is sine over cos. So this is the sine of theta over what? The cos of theta plus. So the moment we say 1 over, what does it mean? It is the reciprocal. I explained this before in our last class. 1 over tan of theta, it simply means the reciprocal. If tan is sine over cos, therefore the reciprocal interchange, cos will be what? On top. So it means cos of theta over what? Sine of theta. The reciprocal of this. That is what it means. So once you see it like this, 1 over tan, this is what we have. So this is cos theta over what? Over the sine of theta. We are back addition of fractions. This time we have the denominators. These are, we have got a complete fraction is different. We've got a 1 like what we had. So here let us properly find our LCM or the LCD of cos and sine. So what is this? It's going to be cos theta, sine of theta. So let's divide cos theta to this. It's going to cancel. You remain with what? Sine. So the sine of theta will multiply the numerator there. So it will be the sine of theta times sine of theta. Okay? The sign that we are given here is what? Plus. We are adding. Remember, it's a plus. We're going to add. We divide again. So as you can see, sine of theta and sine of theta was going to cancel. What do you remain with? Cos. So the cos multiplies what? The cos there on top. So it's cos theta times what? Times cos theta. So multiplying this, guys, what we're going to have, sine times sine is what? Sine is squared. You're multiplying the same trig, sine times sine. So this will be what? Sine squared of theta plus cos times cos. Cos squared of theta, everything over what? Cos of theta, sine of theta. Remember our Pythagorean identity, this one, it is equal to what? To 1. By now, guys, we must be singing this identity. All right, so this is 1 over cos theta, sine theta. Is it what we are having on our final answer, or it is written somewhere? Because we are done with this, nothing that we can do. 1 over sine theta, cos theta. 1 over sine theta, cos theta. This is what we have. Guys, writing 1 over cos theta, sine theta is the same. This one is the same as we are writing as 1 over what? Sine theta, cos theta. Remember, the product of A and B is the same as what? BA. So there is just one and the same, guys. This is exactly what we have on our right-hand side. Just like that. So this is it, guys. From this activity, we are going to add more questions in our next classes, working with similar questions. So just try to peruse through many questions as you prepare for your tests, which are ahead of time.